Number 56. Calculate Ka for the weak acid Ha dissolved in water depicted in the molecular art. Here is the chemical equation that describes the dissociation of Ka as it dissolves in water. And here's the molecular art. So there's something about how many molecules you see in here that's going to allow you to calculate Ka. So I've rewritten the chemical equation on the right and added the phases. So the Ha, aqueous, and water, liquid. And then on the products you have H3O plus aqueous and then A minus aqueous. And here's the molecular art for everybody involved. Now the Ka equation, remember the equilibrium constants are always products over reactants. And here are the two products. So you're going to have the product concentrations raised to the 1 power because the coefficients are all 1s. Acids and weak acids and weak bases are simple to deal with because the Ka equations, the coefficients are always 1, so it's just raised to the 1 power. You don't have to write that. And then over reactants, you got product concentrations over reactant concentrations. You might say there's two reactants. Well, this is a pure liquid, and everybody else is dissolved in that liquid. You don't have to include it in the Ka equation. So we didn't talk too much about that in the chapter on equilibrium, but when you have everybody else is dissolved in that liquid, that doesn't have to be written in the Ka equation. So just leave out liquid water. So here's the Ka equation. Now if we knew what the concentrations are, what these molarities are at equilibrium, then we could plug them in and calculate Ka. But all we have is a picture. Okay, what we're going to do is we're going to substitute for the molarities the numbers of molecules that we see. So let me blow up my little note here. Substitute the numbers of molecules in the picture for the concentrations. So since we don't have the concentrations, I don't know how many moles per liter. I can't plug that in, but we're going to assume that the numbers of molecules that we count in this small volume is going to be proportional to the molarity, and that's actually a good assumption. So I count 2 protons, so that'll be 2 protons right there, and then looking over here I count 1, 2 of the conjugate base A minuses, so I'll plug in a 2 right there, and then I count 1, 2, 3, 4, 5, 6 of the weak acid HA molecules. So that'll be plugged in right there. And then that simplifies to 4 over 6, and the decimal is 0.67.